This one is a little different than the ones that we had before because it's not in factored form. But notice I have a common factor here, so I can factor out our common factor. We have a common factor of x squared, so I'm going to take out that x squared first. So when I take out x squared, remember you're really dividing. So I'm doing x to the fourth divided by x squared, which gives us x squared, and then negative 9x squared divided by x squared, which gives us negative 9. Now, hopefully you see this as a difference of squares, because this is a perfect square and this is a perfect square. And hopefully you remember your difference of squares, that you take the square root of each one. So the square root of x squared is x, and the square root of 9 is 3, and put a plus in one and a minus in the other. What you're really doing is you're saying I need to multiply to negative 9 but add to nothing, so I need 1, 3 to be positive and 1, 3 to be negative, because 3 times negative 3 is negative 9, but 3 plus negative 3 is 0. So now we have this in factored form, so we can tell what our x-intercepts are. So we have the x-intercept of 0, 3, and negative 3. The 0 comes from the multiplicity of 2. Each of these have an unsaid 1, so this is even and bounce. This is odd and cross, odd and cross. Okay, so now notice we can go back to here to find our leading coefficient term. Our leading coefficient term is x to the fourth, which means that since this is even, that it's touchdowning. Since it's a positive, we know that it's going to be opening up, not down. Then we can find our y-intercept. So if I have f of 0, if I plug that in, you can plug it into either one of them. I think it's easiest for the y-intercept to be plugged in here. Notice when I plug in 0 to the fourth minus 9 times 0 squared, that all of these go to 0. Now, anytime you get an x-intercept of 0, you should be anticipating a y-intercept of 0. That's because they're at the same spot. Okay? So now if I put this information on my graph, we have our x-intercept at 0, and it is bouncing, an x-intercept at 3 and negative 3. And both of those are crossing. We have that it's our end behavior of touchdowning with up, up, and this is our y-intercept that's the same spot as our x-intercept. So I'm going to come from the top left. I need to come through, cross through this one, bounce at this one, and cross through this one. Now, where your hills and valleys are, this may be further down, or you may have it so that it's symmetrical. Right now, we're not worried about that specific part of the graph. What we're worried about is our x-intercepts and our y-intercepts and what's happening at the far ends of our graph. So we can easily take what we know about factoring and factor these to get to our graph. Let's look at a slightly more complicated situation. So if we look at this one here, now I'm going to rewrite this so it's in descending order. So negative x to the fifth, negative x cubed, and then plus 6x. So notice I have a common x. So if I take out the x, we also have the first term is negative. So I'm going to take out a negative x. So then I get x to the fourth plus x squared minus 6. Now, you may or may not have encountered this already. Now, notice this is very similar to our factoring for quadratics, but instead of this being squared and this being first, this is the fourth and second. You can still factor these. The way that I multiply to x to the fourth is an x squared and an x squared. Okay. Here, we're trying to multiply to negative 6, but add to 1. So we're trying to say what multiplies to negative 6 but adds to 1. Well, we've got 1 and 6 and 2 and 3. 2 and 3 will get me to 1, with the 3 being positive and the 2 being negative. I double check my signs. Negative 2 times positive 3 is negative 6. Negative 2 plus 3 is really positive 1. So I can put these right here. So one of them will be minus 2 and one of them will be plus 3. Now, this is a little bit different because we have this is an x squared, not an x, and this is an x cubed. But our process to find our x-intercepts is still the same. We're going to set each one of these equal to 0. So if I set x squared minus 2 equal to 0 and x cubed plus 3 equal to 0, here we divide by the negative 1. So we get x is 0. Here I'm going to add 2, so I have x squared equals 2. Well, we don't want x squared, we want x. So to go from x squared to x, we take the square root. When we take the square root this time, we have to do plus or minus. And since this side isn't 0, it doesn't just make it so that there's no plus or minus anymore. So here we get x is plus or minus root 2. If we look at this one, we're going to subtract the 3 to the other side. So I get x cubed equals negative 3. We're going to take the cube root to undo cubing. So we're going to get x equals, when you take the cube root, you don't need plus or minus. You only need your plus or minus on your even roots, not your odd roots. So I get the cube root of negative 3. Now, remember that, oh, hold. I somehow decided to change this from an x squared to an x cubed. Don't do that. I will finish saying this though so that you just know. You can take the cube root of a negative number without having imaginaries. So let's go back and fix this part here. Don't randomly change your exponents. It's not a good idea. X squared plus 3. So we subtract. So x squared equals negative 3. So now I undo with the square root. So we get x equals, remember I need plus or minus the square root of negative 3. When you're taking the square root of a negative, you have to take out the negative 1 as an I. So this turns into I root 3. Remember that this is imaginary, so this will not show up on your graph, okay? Because this is our real numbers and this is imaginary. So this won't show up on our graph of our x-intercepts. These, however, will. Well, I'm not sure what root 2 is. We can guesstimate on what root 2 is because we know the square root of 4 is 2 and the square root of 1 is 1. So it's somewhere between 1 and 2. But if we find the square root of 2, it's 1.41. So we can go to this being plus or minus 1.41. So now when I go to my graph, I have an x-intercept at 0 and at 1.41 and negative 1.41. Now, if I go look at the multiplicities, this came from a first power, so its multiplicity is 1, so it's odd and crossing. Now, this was originally from a squared, but we had to take the square root and we used the plus or minus. So what happens when you have this scenario is that each one of these count as 1. So positive root 2 is a multiplicity of 1 and negative root 2 is a multiplicity of 1. So each one of these has a multiplicity of 1, which combines to get us to the squared. Okay, so anytime you're taking the square root of something other than 0, it turns it into a multiplicity of 1. So each one of these have a multiplicity of 1. And then we don't usually refer to our imaginary numbers with multiplicities. Sometimes we will. When we're talking about how many zeros we have. So notice here I've got 1 0 here, another one here, another one here. So 1, 2, 3, and then 4, 5. Notice our degree is 5. So with all of our real and complex, these being our complex, we have a total of 5 zeros. So the multiplicity plays a part in that each one of these happen once to get to our degree of 5. But we don't typically use these with multiplicities because they're not showing up on our graph. Okay? So each one of these are odd and crossing. So cross, cross, cross. If I look at my degree, our degree is in 5th power. It's negative in front, so that means that our end behavior is like this. Or our leading coefficient term is negative x to the 5th, so then it becomes descending, and it's odd, so it's discoing. Okay, so now I can graph the information that I have from here. Our y-intercept, we've already technically found. If I plug in 0, I get 0. Notice if I plug in 0 here, all of them go to 0, so I get 0. I have an x-intercept of 0, so I should be anticipating a y-intercept of 0. So I'm going to come from the top left. I have to cross, cross, cross. Now again, how high and low you're going right here is not what we're concerned about right now. We want to know where our x and y intercepts are and what's happening at our end behavior. So that's how we can graph when we are able to factor the information.